All right, how is everybody today? Okay, doing well. We're getting back into the routine of things after our first full day back.
Yeah, I finally remembered my class.
Hey, there you go. That's always a good thing. Okay, we are going to continue taking today to review inverse, sine, cosine, and tangent. We spent the majority of the period yesterday talking about those that result in a special right triangle, and we'll go ahead and review those again as well. What I want to spend the majority of today doing is looking at those like in this middle section that will not give you a special right triangle. So we're going to be using the protractor to help us out. So what I'm going to do at the end, we're going to go ahead and take these papers, all the problems that we worked together, we're just going to go ahead and turn them in for a participation grade. So we should start out the 6 weeks looking really good. Tomorrow, we're going to divide it up into two parts. I have an exit ticket based on this same material that we're going to go ahead and look at tomorrow, kind of like a review. That one you'll be able to work together on. We'll turn that in, and then right after that, we'll go into the quiz. So you'll also have a little bit more practice right before we take that. So the quiz is just going to be very similar to what you see here. Could result in a special right triangle, or could be one that you have to measure using the protractor. And I do have a couple of rulers over there if you want to use that with it instead of the protractor. But the only other item, I'll go ahead and mention again, 2 weeks from tomorrow on the 24th. You know, it's still a couple of weeks out, but that's when we have our first exam. Just like the quiz tomorrow, remember you could use your notes. So anything you write down, in fact, this assignment here, I'll pass it back tomorrow so that you also have that during the quiz. All right. Any questions? Everybody doing good today? Yeah? Yeah. Because people, you know, got to give the people what they want. This Thursday, yes, tomorrow. So tomorrow. Okay. Tomorrow's going to be the quiz. The quiz over the inverses. Quiz over the inverses, the material we're reviewing right now. You'll be able to work together on the exit ticket, but not the quiz, yes. So the exit ticket will be a little more review right before you actually take the quiz to help you kind of remember what it is we do. And I've got this here once again. It's always a good idea. I know it probably is going to get a little monotonous, but it's a good idea to kind of think about, you know, exactly what we're doing. When you evaluate a trig function, that negative one shouldn't be there. Sorry about that. When you evaluate a trig function, what do you plug into it? Is it a ratio of sides or an angle measure? Okay, for a normal trig function, you always go ahead and plug in an angle measure. Doesn't matter if it's degrees or radians. Okay, now what answer will you get out of that? That's the ratio of the two sides of a triangle. I just happened to use sine again like yesterday, which would be the opposite over the hypotenuse. If you were trying to evaluate cotangent, it would be the adjacent over the cotangent? Adjacent over opposite. Okay, because remember, cotangent is x over y, the reciprocal of tangent. Okay. Oh, there you go. Hey, there you go. Now, if you're ever given the ratio like we are here, you're going to evaluate that with an inverse trig function. So you plug the ratio in, and that's when you're going to get the angle measure. Okay. And typically, you know, we're going to start out with these being degrees. If we want them in radians, we can easily go ahead and convert that by multiplying pi over 180. All right. Now, when it comes to those that aren't the special right triangles, even though we're about to review them, we're just going to go ahead and keep our answers in degrees. Okay, we're not going to worry about doing this in radians. So here are the two triangles that hopefully we end up with, the 45, 45, 90 and the 30, 60, 90. In terms of x, what were the side lengths of the 45, 45, 90? There you go. They are just x. Now, the pattern here, the behavior, is that to get the hypotenuse, you take the shorter side x, and Brandon, what was it you said? There you go. We take that shorter leg, and we multiply it by the square root of 2. So you're going to be using the Pythagorean theorem to find the missing side, and then hopefully what you get is going to show these patterns here. It's either going to be the 45-45 or the 30-60. Now, we remember in a 30-60-90, x is always going to be the shorter side. It's always directly opposite 30 degrees. But how do I use that shorter side to find the longer leg? Oh, no, that's the hypotenuse. You're right about that. So the hypotenuse is always just double the shorter leg. But the longer leg, you got to take the shorter and multiply it by the square root of 3. That is exactly right. Okay, that's what we're looking for. And if it doesn't fit either of those patterns, that's where the protractor is going to come in today. And that's where we're going to be using those. Well, again, just to make sure we're all on the same page when it comes to the inputs and the outputs. Okay, whatever you plug in, okay, the ratio, there's a specific interval that it has to meet in order to actually get an answer. If we go outside that interval, we're not going to be able to get an answer. In fact, I think we did one of those yesterday, right? We didn't? I could have sworn I showed you on the calculator, but we'll do another one just in case. Okay. Now, both sine inverse and cosine inverse, whatever you plug in, that ratio, they have the same interval. It has to be between what two numbers? Does anybody remember? It's got to be between -1 and +1. So the ratio for sine inverse and cosine inverse has to be between -1 and +1. If the ratio is outside that interval, it's not going to work. You're not going to be able to get an answer. Okay, there's no angle measure. Now, when we're talking about sine inverse, does anybody remember what two quadrants is sine inverse restricted to? 1 and 4. I think, is my music still playing? There we go, just in case. I know, Boston's a great song, band too, so. Okay, anyways. So right there, okay, let's see, what was I doing? The answer, okay, your degrees or your radians, has to be between -pi/2 and pi/2. Now, cosine inverse, what two quadrants was he restricted to? He was 1 and 2. So he was the top half of the unit circle, right? So this was going to be everything between 0 and pi. And if you're thinking of those in terms of degrees, between -90 and 90, between 0 and, what's equivalent to pi? 180. 180, yes. All right. And then what's the restriction, if any, on the ratio for tangent inverse? Yeah, all reals. There is no restriction. Okay, no restriction on what I can plug in. But there is a restriction on what I'm going to get out of this. Now, tangent inverse is restricted to what two quadrants? 1 and 4, just like the sine inverse is. Okay. All right, but there is one difference. While sine inverse can include negative and positive pi/2, tangent inverse cannot. So he is still going to be between -90 and 90, but we cannot include those because tangent's undefined at those locations. All right. So let's go ahead and take one of these. Let's take cosine inverse this time. Okay. Give me a number between -1 and 1. 0. 0 will work. So if I come on over here, okay, document B. So hit trig. Interesting. Okay. Hey, there you go. Hit a random trig function. So cosine inverse, let's go ahead and plug in 0, which is between -1 and 1. So see, I'm going to be able to get an answer. So it's telling me 90 degrees, or that would be pi/2. So that one would actually turn out to be a quadrantal. But if I try to plug in a ratio, some value that's bigger than 1 or smaller than -1, well, then we're going to have, some problem. Let's just say 2. Let's see if it does that again. It did not. Okay. So 2 is definitely not between -1 and 1, correct? But if I still go ahead and try to plug it in, see, it's going to give me this error message. It's not able to do that. Okay, so we have specific restrictions on these. So if you realize that your value isn't going to work, you can probably just go ahead and say no solution. Okay. All right, any questions on what we've talked about so far? Okay. Now, help me remember here. We did number 1, right? We did number 1. I just erased number 4. And then we did 5 and 6? Okay, good. Now, I believe the other two are going to end up being quadrantals. So why don't Actually, let me just go ahead and make another one up. All right. That way we'll go ahead and get another little review on that out of the way. Let's say I want to try to evaluate, tangent inverse of 1. Okay. Now, one thing that I didn't mention while we were looking at our review, we were talking about these quadrants here that the inverses are restricted to. Like for tangent inverse, there's 2 quadrants to choose from, right? 1 and 4. Well, how do I know which one to go ahead and draw my triangle in? There you go. You make that choice based on the sign. Since 1 is positive, we're going to put that in quadrant 1. Okay, so here's my coordinate grid, the x and the y axes. So I'm just going to draw my terminal side. Okay, I'm choosing 1 because it's positive. Had it been negative 1, well, I would have just been drawing it in quadrant 4. Okay. So I always connect this to the x-axis. There we go. So I'm looking for this right here, theta, right? Okay, well, what is tangent's ratio? It's always y over x, right? Okay, so y over x. Well, how can I write 1 as a fraction? Yeah, just 1 over 1. So this is telling me that the y value of the height is 1. The x value, the horizontal, is 1 as well. Now, we want to find r. Okay. And remember, we mentioned the Pythagorean theorem. So you always square and then add the 2 sides that form what? What angle? The 90-degree angle. So here it would be 1 squared plus 1 squared is equal to r squared. Well, what's 1 squared? 1. Okay, so 1 plus 1 will give me 2 is equal to r squared. And how do I get the radius r? Yeah, take the square root. So this should be the square root of 2. Okay, now here's my question. Okay. Is this one of my special right triangles? Yes. Which one? Now, how do I know this is a 45-45 and it's not a 30-60? There you go. You'll notice one huge condition, if these 2 legs are identical, it's going to be a 45-45. The other idea is if you can take one of those legs and multiply it by the square root of 2, that should give you the radius, right? Well, what's 1 times the square root of 2? Square root of 2. So this is a 45-45, 90. There you go. So tangent inverse of 1 is 45 degrees. Okay. The only other thing, remember, if you're trying to simplify sine inverse or tangent inverse, and you're in the 4th quadrant, guaranteed your answer is what? It is negative. Okay. If your graph ends up in quadrant 4, your answer is going to be negative because you have to rotate that direction to get there. Okay, good. Good, good. Well, let's go ahead and take all this off because that's what we did yesterday. We were just remembering how to do that with special right triangles. But now, what if we come across some that are not special right triangles? Okay, like this guy right here. Let's just start with number 7. Cosine inverse of 0.75. Okay, so we're going to make this a little easier. What's the fractional equivalent to 0.75? 3/4. So I'm just going to go ahead and say 3/4. Okay. Now, we're going to do the exact same thing. I mean, I'm telling you that, it's not going to end up being a special right triangle, but you always approach these problems the same way. Okay? Right, Genevieve? Right, Genevieve? Right? Here we go. All right. So let's see here. First, I have to decide what quadrant this is going to be in. Okay? Why the first one? Because we could have the first or the second for cosine inverse. Because it's positive 3/4. Okay, so let me move this over here so it's a little better. So is everybody okay with why I'm choosing quadrant 1? Okay, so I'm going to draw my terminal side right here. Okay, now I'm going to go ahead and connect that to the x-axis. Now, what is cosine's ratio? Okay, x over r, right? Okay, would everybody agree? Okay, so if here's theta, then the adjacent x is 3, and the hypotenuse is going to be 4. Would everybody agree? Okay. Well, now, let's go ahead and figure out what this one's going to be right here. So that's y I'm looking for. What's the equation I would need to create using the Pythagorean theorem? Okay, so 3 squared plus y squared equals 4 squared. Is everybody okay with that? Okay. So now what's 3 squared? That is 9 plus y squared is equal to 16. Subtract the 9 over. So y squared, what is 16 minus 9? 7. And how do I find y? Take the square root. Okay. So it should be the square root of 7, right? Okay. Well, this is our first example. I mean, if you take a look at the triangle we created, okay, well, you'll notice, why isn't it 45, 45, 90? There you go. Those two legs would have to be identical, the two sides that form the right angle. So immediately 45, 45, not even an option. Why can't I even say 30, 60, 90? Yeah, so first, the hypotenuse should always be exactly double the shorter side. Okay, so if I were to double 3, am I going to get 4? No. And also, if I took the shorter side, if I multiplied it by the square root of 3, it's not going to give me the square root of 7. Okay, so this is one of those cases where we're going to have to measure. So I still want to know what this angle is right here, right? But I'm going to have to go ahead and change this using my ruler. So I like to go ahead and measure in centimeters. I mean, you can measure in inches if you want to. It's just that sometimes if your values are a little larger, it's going to take up more space. Okay, I mean, you're more than welcome to. So let's say this is centimeters right here. Okay. Now, the only problem here is if it's not a whole number, like here, if it's the square root of 7, well, let's see how many centimeters we're actually looking at. So let's see, square root of 7. Okay. Enter, enter, enter. There we go. So about 2.65, right? Okay. Now, why don't we go ahead, what was it that we did? Does anybody remember before the break? How were we able to get a more approximate measure instead of just trying to figure out where 0.6 was on centimeters? No, we don't use a trig function. We multiplied it by one number. We multiplied it by 10. Okay. Now, multiplying by 10, what's that going to do to this guy? It's just going to move the decimal over. So it's going to end up being 26.45. Well, I actually changed the centimeters to what? Millimeters. So see, that's going to be much more accurate for me to figure out where 26.5 millimeters is instead of 2.6 centimeters. Does that make sense? Okay. Everybody okay with what I've done so far? Okay. So I'm going to come back over here. So I know that I'm looking for a triangle where I'm going to have, and I'm going to go ahead and change this. If I have 3 centimeters, that would be 30 millimeters, right? And then what did we end up with? 26.4? Was it 45? Okay, you're right. 45. So I want to go ahead and create a triangle that has these measurements, and then my protractor is going to help me figure out what that angle is. Okay. So I'm going to come over here. Let's use my ruler now. And I believe a lot of your protractors do have centimeters on there. It might be on the inside bar here, but that's fine. If you don't want to use that, like I said, I got rulers over here. Okay. So let's see. Let me go ahead and set this up correctly. So first off, I need to go ahead and measure, because every centimeter is 10 millimeters, so 10, 20, 30. And you'll notice I'm not putting it right at the edge of the ruler, I'm putting it where the measurement starts. So I'm going to go ahead and make a little mark right there. So did everybody agree that that is 30 millimeters? Okay. And then from there, let me go ahead and move this vertically now, if it'll work with me. If it will cooperate with me. There we go. So at that mark that I made, okay, now I want to go up, how far was it? 26.5. Now remember, every centimeter was 10, So we have 10, 20, 26.5, maybe right about there. Okay. Would you guys agree with how I've marked it? Okay. So, I mean, you could go ahead and draw the other sides of the triangle if you wanted to. I'm going to start at the origin, and I'm going to go ahead and draw a line straight through the mark that I made. I went 30 millimeters by 26.5. Okay, so let's see what this looks like. If it will let me do that. There we go. So let's see. I'm going to go ahead and make that longer because I'm going to use my protractor here. So would everybody agree I went from the origin right through that point I marked? Okay. Well, let's get rid of the ruler or make another line. Now let's get rid of the ruler and let's bring my protractor over. Now, how am I going to use the protractor? How do I want to put this on my grid? There you go. So the crosshair is right here in the middle. I'm going to put that right on the origin. Okay, so I'm going to move this guy right over. See how I'm putting the crosshairs right on top? Okay, so Marcus, I would agree you're saying about 41 degrees. Now here, because of mine, I'm having to use the inside track. The other one is if I were rotating the other direction, the outside track. So according to this, I would say probably about 41 degrees. Okay. Now let's go ahead and see how close we actually got. I didn't have the calculators out because I wanted to, we're going to focus on the protractors today. And one of the problems tomorrow, you'll be doing this. So let's see, cosine inverse of a 0.75. If I come over here, hopefully my measurements are going to turn out nicely. Cosine inverse of a, what was it, 0.75? Point. It is finally taking it. Enter. Okay, so did it finally come up? Hey, it finally came up. There we go. 41.4. So how close did we get? We actually got really close. So I gotta give myself a pat on the back. Okay. Oh no, but I was the one who I measured it. Yeah. So I guess you could say we both ruled. I used a ruler. Okay. Anyways. There we go. Okay, but that's it. Now remember that one, it probably seemed a little longer than it needs to be just because, again, that was the first example. But now that we know what we're doing, okay, it'll go a lot faster now. Let's look at another one of these. Okay, and I'll let you guys decide. Which one would you like to look at now? 8 through 12. You want to do 12? Okay. So let's see here. Let me go ahead and get rid of all the rest of this so I don't need. Let me get the protractor out of the way. Okay, don't need this guy anymore. And, oh, okay, come on. Okay, I'm going to do this with the mouse. Because the sensor, it looks like I have to calibrate it again. And that's okay. Okay, let's get rid of that. Okay, so we wanted to do number 12. So we do want to do another cosine inverse? Okay, sounds good to me. And I mean, really when it comes down to it, if we're looking at tangent inverse, would I be drawing this guy in quadrant 1 or 4? By 1. It's positive. So quadrant 1. And let's just, go through those. Sine inverse, because it's positive again. What about cosine inverse of 5/8? 1. Now, here's what's interesting. Number 11, tangent inverse of a negative 0.4. That would have to be quadrant 4. And because it's in quadrant 4, I know that my answer would have to be a negative answer. Okay. We're going to go ahead and do number 12. Cosine inverse of the square root of 2 over 3. So again, this one's going to be in quadrant 1 because it's positive. If it were negative, it would have been in quadrant 2. Remember, cosine inverse is 1 and 2. Sine inverse, tangent inverse is 1 and 4. Okay. So let's go ahead. I'm going to draw a little one over here for my diagram. So we know it's in quadrant 1. Now, it's the same function. Brandon helped me out a moment ago. He said that was x over r, right? So this one's already a fraction. What's the horizontal, the x value? Would that be square root of 2 or 3? if I were to compare this to x over r, is square root of 2 the x or is square root of 2 the r? There you go. See, we're just comparing them right next to each other. So that means this is the square root of 2, so r, the radius, would have to be 3. So I'm looking for the y value. Is everybody okay? Now, how am I going to find that missing value? Pythagorean theorem. Okay, once again. So because y and the square root of 2 are my legs, I'm going to say the square root of 2. Whoop, forgot to square that. Let me erase that. Square root of 2 squared plus y squared is equal to 3 squared. Okay, so what's the square root of 2 squared? Okay, 2, very good, plus y squared equals 9. Now I'm going to go ahead and just put this right here. If I were to subtract the 2, y squared equals 7. So the height that I'm looking for is the square root of 7. Okay. Now, just by looking at the patterns we're already accustomed to, is it 45-45 or 30-60? No way. It is neither of those. So again, we're going to have to measure, right? Okay. So let's figure out square root of 2 and the square root of 7. Hopefully the calculator will work with me on this one. Square root of 2. Okay. Okay. There we go. It's finally coming up. And we just did the square root of 7, right? Let me go ahead and pull that up one more time. Okay. Now, I would probably go ahead and take these in centimeters. Again, you can start those with inches. But especially if it's not a whole number, to get a more accurate measure, what would I do to each of these? Yeah, just times by 10. We convert the centimeters to millimeters. So really what I'm looking for is a triangle that's, let's say, 14.1 horizontally with a height of 26.5. Okay, because that 5 will round it. So let's see here. If I come back over here, instead of square root of 2, I'm going to go ahead and put the 14.1. Remember, all we did, we just multiplied the value by 10 to get millimeters. Is that okay? And then the square root of 7, 26.5 again. It's supposed to be a 5. It just got caught next to the ruler. Okay. So I'm going to measure that right here in quadrant 1. All right. Now, is there any questions on what I've done so far? Hey, Brandon. Oh, because these values, the square root of 2 and the square root of 7 were my original lengths, right? Okay. So I know these here are going to be in centimeters. So all I want to do is multiply each one of these by 10. I just didn't show that. So like, for example, I've got the square root of 7 as the previous answer. If I go ahead and multiply that by 10, it'll let me do that. See, it's just going to move the decimal 1 over. So if I multiply 1.41 by 10, that's where we got the 14.1. Okay, good, good, good. Any other questions? All right. So let's see here. Come back over. I need my ruler once again. Okay, let's make sure this is horizontal. All right, so I need to go first horizontally 14.1. So let's say here's 10. So would you agree 14.1 right about there? Where I made that little dot? Okay. Now from that dot, I want to measure up 26.5. Okay. So let me turn this guy vertical. So again, I'm going to start measuring at the mark, not the edge of the ruler. Whoop, I'm a little off on that. There we go. So now I want to go up from that mark 26.5. So let's say 10, 20, 26.5. So, whoop, a little low. So maybe right about there. Would you guys agree? Okay. Now from the origin, I'm going to go ahead and draw a line right through that mark that I just made. Okay. So here's what I've done so far. I measured 14.1 millimeters horizontally, 26.5 millimeters up. Let's see if it will actually let me do it now. There we go. Start it off. Okay, so from the origin, I'm going to draw a line straight through that mark that I made. Okay. And now let's see what the measure is. And hopefully I get as close as I did on the previous problem. So what would you say for this one? From the x-axis, if I rotated counterclockwise. 62? Okay, would you guys agree? Do we say our answer is about 62 degrees? Okay. So let's say this is about 62 degrees. Well, let's see how close we got. It was cosine inverse of the square root of 2 over 3, and I already know I should probably use the mouse to help me out with this. So let's see. So cosine inverse, control divide, the square root of 2 over 3. We said 62, 61.8. So how close did we get? We got really close. Okay. Is there anybody who is not seeing how we're doing this? Okay. Anybody confused? Okay. Now, here's the thing. You're going to have the calculator tomorrow. I do want you to go ahead and draw it. Try to figure out what the measurement is, using the protractor, and then match it up. Okay. We don't want to rely just solely on the technology to help us out here. Okay, questions? All right, good. Well, we should have time for one more. Is there one more of those that we'd like to go ahead and look at? We did 7 and 12. Do we want to try a sine or a tangent? Okay, which one? Here, instead of trying to delete these, I'm just going to move these over to the side. Oh, it came back. It doesn't want to get out of here. Oh, there we go. There we go. Just get rid of them that way. Okay, which one do we want to look at? 11. Okay, let's do tangent inverse. Okay, give myself a little bit of room here. Okay, so I'm going to go ahead and draw just a coordinate plane. Okay, now, first off, can anybody tell me negative 0.4? What would that be as a fraction? Net 4 over 10. Very good. Because remember, when you divide by 10, it moves the decimal over, right? So negative 4/10. Boom, we got lucky. It was almost 2/10 in here. 2/10. Oh, crap, I did. Oh, there it goes. Okay. But that does reduce to negative 2/5. So negative 0.4 is negative 2/5. So I'm just changing it because we're going to create a triangle. Okay. All right, so now we're looking at number 11. This will be our last example. Tangent inverse of negative 2/5, right? What quadrant? 1 or 4? By 4. It's negative. Okay, so I'm going to go ahead and draw a terminal side right here in the 4th quadrant. Always connect it back to the x-axis. Now, the only thing is, remember, tangent inverse, what's his ratio? It's always y over x. So if this is the angle that I'm looking for, theta, then the 2 would be here. The 5 is the adjacent. Which one's negative? Would have to be the 2. Okay. And this time we're looking for the radius. All right. Now, in fact, we could go ahead and do that, and if you want me to, I will, but is there any way it could be a 45, 45, 90? No. Is there any way I can take the shorter leg, multiply it by the square root of 3, and get 5? No. So it's definitely not one of the two special right triangles, right? Okay. So really, we don't need the radius in this one unless we just want to practice finding it. Did anybody want to do so? No? Okay. Now, we also don't even have to worry about using the calculator because we don't have any radical lengths. We can just go ahead and say this is 5 centimeters and this is 2 centimeters, right? Okay. So this one's actually really nice to us. Now, even if you did get a decimal from a radical, you just multiply it by 10, you got your millimeters, just like we've been doing. Okay. So let me go ahead and pull this guy down here a little bit because I want to be in quadrant 4. So starting from the origin, I need to measure 5 centimeters horizontally. So let me get this guy over here. All right. There we go. Okay, so measure from the mark. Okay. So there's 5 centimeters right there. Would everybody agree? Okay. Now from that mark, I want to measure down how far? 2 centimeters. Okay. So let's see here. So I'm going to go ahead and kind of do it backwards this time. I'm going to put the mark for 2 on the, there we go. The mark for 2 on the line right there. Okay. So let's say right here. Oh, went a little low. There we go. Would you guys agree? Okay. And then once again, from the origin, I'm going to put a line straight through that point that I just made. Okay, so we get rid of the ruler. Let's see if I have a, let me test it out. It is giving me a line. So from the origin, I'm going to go straight through that line that I just made. And remember, this right here was the 2 centimeters we went down. Now, the only thing I'm going to have to do is invert. Of course it did. Whoa, what happened? Okay, so I'm going to take this guy right here. Of course it did. There we go. So let's see. I'm just going to have to turn this upside down because we're in quadrant 4. So I still want to go ahead and put the crosshairs on the origin, just like I've always been doing. So let's see. I'm going to line it up just like that. Now in this one, we're going to be using the outside track, okay, because of the way my protractor is labeled. So what would you say? A 22.5? Okay. But don't forget, the answer has to be what? Negative. Why negative? Because we're in quadrant 4. So let's say we wanted to round this to the nearest degree. You want me to say 22 or 23? 23? Okay. So let's say this one right here is about a negative 23 degrees. Okay. So let's see how close we got. Tangent inverse of a negative 0.4. Now I'm just going to go over here to the calculator. Sorry, sir. So let's see. Tangent inverse of a negative 0.4. Let's see if we can make it 3 for 3. So negative 21.8. We chose negative 23. Is that still really close?
Yeah.
I'd say that's good. Now what I'm going to do, the one problem on the quiz where you're measuring with the protractor, I'm going to go ahead and give you a leeway of 5 above and 5 below. So a good interval, just in case your measurement is a little off, you can still get credit for that. Does that make sense? Okay. All right. And that is it on inverses. Any questions? Okay, cool. Thank you guys very much. If I can get you to put your protractors back.